Hey everybody, doing some homework here. Item 4 looks like one that I wrote here. An object starts at position x1 at velocity v1. It speeds up in the positive direction until it reaches velocity v2. Write the algebraic expression from the acceleration time graph. All right, so we're working graphs because graphs are awesome. Graphs are great. So let's see if I'm going to do the acceleration. Well, hold on a second. I need to draw a picture of this thing first. All right, so there's this guy. He's at some position x1, moving at some sort of velocity v1. It speeds up in the positive direction being to the right as it typically is. There we go. There is my plus x right there. And at some later time, I'm going to be at some other position right here, x2, and it's at a faster velocity than it was before because it says it speeds up. I could make this x equals 0 if I wanted to, but really it's not terribly that important because often, again, we are just concerned about the displacement between these two guys here. That's my delta x. How far did you go? All right, now back to drawing our graphs. Why do that first? Because it really helps with this. I'm going to make my velocity time first. I know it asks for acceleration. I could probably do the acceleration if I wanted to, but I'll just do it. Okay, acceleration. Logically, what's going on here? I'm moving in the positive direction. If I'm moving in the positive direction and I'm speeding up, my acceleration is going to be positive. There we go. Now I can move from there, but let me just think about, does this all mesh? So my velocity initially starts at some value right here. And then that's my V1. At some time later, I'm at a higher velocity, V2, that is a bigger positive value. There you go, there's my two dots, connect them with a straight line. And I have a positive slope that matches with my acceleration graph there. Wonderful, great. Okay, now, from here, what to do? Question says, write the algebraic exponent for this right here. Find delta V. All this whole delta V right there. Well, delta V is equal to acceleration times time. Right? Now, if I put that in there, let me do one other thing first. When I'm writing this, you might think, okay, I'm in the x direction. So if I do a shift underscore x times time, right? Does that work? No, it doesn't. Doesn't depend on a sub x t. So maybe I need to put a little times in there. Nope, it gives me the same thing, right? So that little times there doesn't work. So it doesn't depend on a sub x or t. What does it mean by that? Well, I definitely have a time in there. Maybe it's just I don't need a sub x. Maybe I just need a. So I'll do t times a, and I push submit in there. It doesn't depend on t times a. Oh my gosh. How if I put a little guy right there? Interesting. How do I do a times t? Oh my gosh. That is annoying. All those were just right. All those are perfect. But if you're putting it in there and all those things are right, oh my gosh, that's really frustrating. So I'll have to see if I can change that, as in it doesn't have to be that specific format, but hey, there we go. All right, it's in there. Now, for this, there we go. And then I have another one that I have to use. I use this color. There's my two delta x's. We've kind of done this before. There's my delta x. Let's call this 1, and I'll call this delta x2. Okay, but I want the expression, write the expression from the velocity time graph. Okay, so we'll see if this guy here is just as annoying. So delta x total is equal to delta x1 plus delta x2. Right, probably should have color coded that one, but delta x total is equal to delta x1, which is just v1 times t plus 1/2 times time times c. This is v2, which means the height of this is my change in v, delta v. Excuse me. Okay, hopefully this guy here isn't as picky. V shift underscore 1 times time plus 1 half times t times slash delta. Oh, wrong delta. I need capital D. Delta. V. Are you going to give it? You going to do it? Okay. So it just so happens I put everything in the right order. My guess is if I try to do it again in some other order, maybe it doesn't like that. Yeah, maybe I should have tried that intentionally, but I didn't. Okay, moving on. Moving on here. Solve for the final position x2. Okay, so from here, I'm going to solve for my final position x2 in terms of delta v x. So if I want x2, right, what is x2? Delta x1, delta x2, right? Those, don't confuse that with like x1 and x2. This delta x2 right here that I have drawn, right? I know it might be, I'm limited in my symbols, people, right? This delta x2 is like the additional displacement from the blue shade on the graph, right? That it is not the pink delta x up here. It is not that pink delta x, not that guy. Okay. This delta x2, when I'm trying to solve for my total displacement, right, is delta x1, which is the area of the orange, right? The displacement due to the fact that you're speeding up, plus the displacement of this blue shaded area here, which is the displacement due to the fact that you are moving at a constant velocity, right? So that's kind of neat. The total displacement is the total velocity, the total displacement from a constant velocity plus the displacement due to speeding up. This x total, right? That's what this little guy is right here. This is delta x total, right? So delta x total is x2 minus x1. So x2 minus x1 equals all this stuff, right? So if I just want to solve for delta x2, I have to add x1 to both sides. I'm going to try to have a little fun here, and I'm going to put things in some sort of odd order. I'm going to do 1/2 times t, oops, that's 5, times t delta v plus, I'm going to do x1 now, and I'm going to do plus, oops, don't want to put that there, plus, I'm going to do t times v1, t v1. Let's see what it says. I mean, this is right, and that says it's correct. Why did it take it that time? I don't know, right? I don't know why I didn't do it for that one, right? But the whole point is I could put those in any order and still the same thing. I could put it as t times delta v times 1/2. I could do t delta v over 2, right? It's all the same. If you're there, you're great. It's awesome. Okay. Well, which graph did you have to make to solve this problem? So I have my two graphs. Sometimes I have to use both, but the question is if I want to know, it speeds up in positive direction until it reaches velocity v2. Oh, so if I'm solving for the final position, sorry, this should be something that comes along straight from part C here, right? From part C, I just want to know x2. If I'm trying to solve for x2, come down here, v1, that's given. Okay, stamp, right? v1 was given. My my x1 is given. What else is given in this problem? Goes to v2. Oh, okay. So if I know v2, I know delta v because that's v2 minus v1. But it doesn't tell me time. Right? It doesn't tell me time, which means I would have to use both graphs to solve for delta x2 here, because to solve for time is delta v over a, or yeah, delta v over a. Does it tell me this here? Delta v over a. I'm just gonna put both here. It looks like I need to fix this question. Incorrect. Velocity time. Velocity time. Yeah. The problem is I don't give you time in there, do I? I'm gonna have to change the question. I'm gonna put time up there. I'm gonna update this a little bit, but here's where it is right now in terms of this this setup. Okay. If you're done, you're done. If you want to listen to an explanation, give me a second. Okay. So we have our guy. He moves a certain amount of time. Okay. It takes him out a certain time to speed up. Go to from x1 to x2, speed up from v1 to v2. You make both graphs, you get two equations, right? You get this guy right here, which is v1t plus 1/2 t delta v plus x1. That gets you your final position, right? So you might have to just start with the velocity here. And if that velocity, if you know the v1, if you know delta v, you know x1, and it gives you the time, this is the only graph you would have to make to actually solve this problem, right? However, if you weren't given time and you were given acceleration, then you would have to include the acceleration graph to calculate the time to put it in the other equation, right? In terms of this one, we're going to be given time, right, eventually, and then all you would have to do is use the velocity time graph to solve for what your final position is. All right. Thanks for watching. I hope it was somewhat instructional for you. It helps you solve other problems of physics. Right. See you.